Today's lesson, section 6.2b, we're talking about trigonometry of right triangles. So here we'll be talking about elevation and depression. So every angle in the real world is kind of one of these two if you're in an observer's point of view. So there's a line called the line of sight, and this line is from the eye of the observer. So like if you were looking at a tree, it's the line from your eye to the point where you're looking at on the tree. So the line from the eye of the observer to the object being observed. Okay? And you can either go have an angle of elevation. So like for the tree, you could have from your eye to your line of sight, but then have a angle, so going up towards the top of the tree. So angle of elevation would be the angle between the horizontal and the line of sight above the horizontal. Okay? So let's say you had your tree, your person, and you were looking at this tree. Okay? Sorry for the picture. So here's your line of sight, and then the top or above, so then the angle between these two lines is the angle of elevation. Okay? So going up to that new point. And then angle of depression is like if you were standing on a cliff and your line of sight would be up here, straight across, but let's say there's a boat down here, okay, then its horizontal is down here, so then the angle of depression would be going down. Okay, so you can think of, the definition of angle of depression is the angle between the horizontal and the line of sight below the horizontal. There you go, I fixed it. So the angle between the horizontal. So you can think of angle of elevation as, if you think of the line of sight as the initial side of an angle on the unit circle, and then the angle of elevation would be a positive angle going counterclockwise around the unit circle. And then angle of depression would be a negative angle going in the opposite direction, okay? Or going clockwise. So those are the two differences between elevation and depression. So now let's use those. So example 2, a giant redwood tree casts a shadow of 500 feet long. Find the height of the tree if the angle of elevation of the sun is 20 degrees. Okay, so you have, and I always like to draw pictures because it makes it easier to understand what's going on. So giant redwood, and I know this is not the scale, nor are the colors, but whatevs. So you have this giant redwood, and the sun is up here, just chilling. Okay, and it casts a shadow that is 500 feet long. Okay, so that means that this angle of elevation, okay, because it says angle of elevation, you know that it's coming, they're talking from the top of that shadow towards the sun. Okay, if they were saying angle of depression, you know that the sun is the observer in this case. The bottom of the, so then since it's elevation, the tip of the shadow cast is the angle of elevation, and it says it's 20 degrees. Okay, so now you have these two pieces of information. You want to know the height Okay, so then now you need to use one of your trig functions. So here you have the opposite side, and then you also have the value of the adjacent side. You want to find the opposite side, so that means you need to use tangent. So tangent of 20 degrees equals h over 500, so opposite over adjacent. I would multiply both sides by 500. Okay. So then h should be that the height of the tree is 181.99 feet tall. Okay. Since I have a label or unit of measurement, I would need to put my label in there. Okay. Now also, I want you to add on to the table that we made in the last video. Okay, so we had this part from the last video, and we already discussed where it came from because it came from the 30-60-90 triangle and the 45-45-90 triangle. Okay, now because you know that cosecant, secant, and tangent are cotangent are reciprocals of sine, cosine, and tangent, then let's add these ones to the end. So the reciprocal of 1/2 for sine for 30, cosecant would be 2. For secant, the reciprocal would be 2 square root of 3 over 3 from cosine. And realize that all these values I rationalized if they weren't already rationalized to begin with. You don't have to, so if you want to leave secant as 2 over square root of 3, that's perfectly fine. It's not a big deal. And then for cotangent, it'd be 3 over square root of 3, or if you went back to the original triangle that we talked about, the special one, you would get 1 over square root of 3, which is alright as well. Okay, so just go ahead and copy that down, and then that's it for the day. Okay, have fun.